Alright, welcome back. I'm Gadget Girl again, and this is my first real lesson for my PoserPython tutorial. If you were paying attention, by the way, it's a minor thing. I changed the materials I was using here on this dress. I like this red better for this purpose because, as you will see, it's a lot more obvious than sort of the gray and the black thing we had going on before, what some of the problems are as we try to render it. We're going to kind of let that run for a minute in the background. And that's what we want to do. Yeah, that's not good. That's not what we were looking for at all. We want to fix some things. And if you look up here, when I started to render that, we got all of this mess here. And that's the problem we want to solve. These are great textures for Firefly, not so great for Superfly. So one of the issues, and the thing that's kind of dulling out this metal brooch here, if we go back, that's what it looks like here, and no. So that is part of the stola. And what's happening there is a couple things. Part of it is ambient occlusion, which does great stuff in Firefly, not so much in Superfly. So we want to get rid of ambient occlusion. But if we actually go in and we look at this material for the stola, there's a lot going on, and in fact just happens that ambient occlusion is hidden under there. And although this doesn't have as many materials as, say, the dress has a whole bunch, we still don't want to have to go through material by material and manually delete this. Even if we were to copy and paste these materials as we cleaned them up, we still kind of got to go in one by one and paste them. Although I do believe other people have made scripts that makes that easier. But that's the point. You have to make a script to make that easier. Otherwise, it's a long, tedious process. So that's what we're trying to accomplish. That's the first thing. It's going to take a while till we get to the point where we're going to clean up her skin here. If you don't remember, the skin texture is going to show up as, excuse me, as kind of gray. We're not going to get there for a while. We're going to start with something easier because, as I said, this is for people who have no coding experience as well as if you have some. So we need to understand a couple things before we can really start coding. We need to understand variables and functions, which also have this and/or definitions. So a variable is something you probably learned about in math class. So if x equals 5, x plus 2 equals 7. Same thing if y equals 5 or banana equals 5. Whatever the variable is this part. So this actually this part down here is a series of steps you want to repeat over and over. That's a definition or a function. And we could call this add to, which is not very interesting, and it would take a number. And if this were a Python script, we would say that a number plus 2 is what we want this to. We're going to say result. So this is a little bit of Python code. Actually, you'll see if I copy it into this window here, because this window, oh, and I have a typo. This window knows that it's Python. This is just kind of for me to type in. This window actually knows it's Python. So right here we have both a variable and a function. And the reason they're also called definitions is the way you let Python know that what you've made is a definition or a function is with these three letters, DEF. So in this case, we've made a definition called add to. It takes a number, and in that case, that could be x, that could be y. And, oh, we want it to do one more thing. We would want it to return result. So this is not a very interesting thing, but we're going to go ahead and run it anyway, and then we're going to not worry about these less meaningful ones. So we're going to say x equals, no, you know what, we're going to say banana equals 5. And then we are going to call add to banana. And then we are going to print, actually we're going to print up here because this just can be really simple because this is just to give you an idea. So I'm going to save this. It's actually called delete nodes because that was what this was going to be for and it will be for. So I'm going to run this from the file menu. I actually have my finished versions of the scripts up here. The reason I'm doing that for now is it's a lot of times easier when you're editing as much as I am right now. So we are going to go back to where I have this. There we go, delete nodes. We're going to open it, and it just prints out 7. It's printing what add 2 plus banana is. So not super exciting, but that is a definition and a variable. So the reason I started off with that, even though it's not all that exciting, is because in a moment we're going to figure out how are we going to solve this problem. And you really can't do anything in coding without variables and functions. So what is our problem again? Let's just remind ourselves. Our problem at the moment, the one we're going to start with, is that this ambient occlusion is destroying our shininess. And we want to get rid of ambient occlusion pretty much in the whole scene, but we're going to start by doing it one at a time. So the way we're going to figure out how to code this is to start by figuring out how we do this by hand. So we have to open Poser. And if you're wondering, and hopefully noticed, I have this little hashtag here, or pound sign. It's technically an octothorpe, which is one of my favorite words, but I'm probably going to call it a pound sign. This creates what's called a comment. So if you remember a few minutes ago when I ran this script, we got that result of 7. If I run this script now, we're not going to get anything because all this is a comment. And basically Python ignores anything here. And that's really useful for a couple reasons. One is it lets us make notes to ourselves so we can read our scripts or other people can read them so we can remember why we did the things we did. It can also be useful if we've made a mistake or we think we have. We can do, so if I bring this guy back over, we'll copy and paste him back over. If I'm not sure this line, oh, and there we go again there. I did have a mistake because I still have that wrong on the other side. You know what, just so people don't look at that and think that's wrong, even though that part's not really code, we're going to do that. Okay. If I'm not sure this is doing what I want, when I do this, you'll notice it turns gray again. And at this point, it's not going to run that. In fact, I'm probably going to get an error because I have a definition that does nothing. But this is a really useful way of testing, hey, I want to try it without this line of code. Oh, look, my line of code is back. So that's another reason we use these. And in this particular case, I'm doing something, it's not, you'll sometimes hear programmers talking about stubbing out something. That's kind of what I'm doing here, but I'm going to do it in human language. I'm just going to do it with comments, and what I'm trying to do is set up what are the steps we need in order to accomplish getting rid of this ambient occlusion. So like I said, the first one is we need to be in Poser, and we need to be in, oops, wrong character, we need to be in, we need to open a scene. And we need to choose a figure to work on. And then we need to find the materials on that figure. And then, once we've found those materials, wait a minute, well, maybe we've skipped a step, maybe not. There's a couple ways we could do this. We need to know what we want to delete, because this is our delete script, want to delete. So we need to know what we want to delete, and then we need to see if are any of the nodes of our shader, or sorry, our material, the ones we want to get rid of, and then finally we want to delete the nodes. Okay, this is what we want our script to accomplish. And the reason I've laid it out like this is we're going to need to figure out what are the variables we're going to need, what are the functions. This is the problem we want to solve. And some of these steps, like I'm not sure yet. Do we want to figure out what we're deleting first, or do we want to find these materials and figures first? We now know this will keep us from kind of forgetting what we wanted to do. And that's why I like this is often a good way to start out, is just to make these notes. What am I trying to accomplish? What are all the steps I need to go through and accomplish what I'm trying to do? Now, our script isn't actually going to open Poser for us, but we have to let Python know we're using Poser. And so every script we write in this is going to start with import Poser. What this is importing is not the entire Poser application, but what is called a library, basically a whole bunch of scripts that have been provided to us by Smith Micro to use in Poser. That's so we don't need to write a script that figures out what a material is and a ton of other things, which will start to make more sense as we start to access these scripts. So these scripts, and I should say these scripts and functions and definitions, this is going to get us to a whole bunch of things that Smith Micro's already made for us so that we don't have to redo that. So the next thing is, again, our script isn't actually going to open the scene, but we want our script to know what scene we're in. And the way we find our current scene is poser.scene. Spelling does count. Poser.scene. So what this is doing is this is going to look at this poser library we imported, and it's going to go and look for a function called scene. So a lot of the times when you call a function, meaning say, hey, go do this function, you're going to use this dot notation. We're not going to worry about it too much at the moment. So this scene is a function in our poser library. Let me just add library is a series of pre-built functions, scripts. I'm just going to call it that because I don't really have the ins and outs of this poser library in terms of I'm not looking at the actual source code. I don't really know whether it's just a function, whether it's, how it's going through. We don't really need to worry about that. We just need to know that when we tell it to import poser, we can then find our current scene by saying poser.scene. But this may not always be the scene we're working on. This is the scene we're working on right now. We want it to work on any scene we're ever working on. And so we need a variable to do that because the scene might be this one, it might be another one. So we're going to declare a variable and we're just going to call that scene, or that variable scene. So this is like x was over here. You'll notice we have the same notation, x equals 5, scene equals poser.scene. We could call this banana, as we did in our example, but we really don't want to. We want our variables to have names that make sense so we can keep track of what we're doing in our code. Now, some people will do a real shorthand. They'll just do like s equals poser.scene. I don't recommend doing that a lot because it's very easy to lose track of what you're doing. Every now and then I might do something like that if maybe I'm referencing all kinds of scenes, and I just want to specify the one that I'm at this point. That may not make sense at the moment. It probably won't make sense for a while, but we want to make variable names that make sense. Now, for any of you who've ever actually done any coding before, you may be looking at this and saying, but what is this? What type is this? It's what kind of variable? How do you know that's a variable? So Python makes declaring variables very easy. We don't have to tell it variable scene. In our example over here, I don't have to say int x equals 5. I just can say x equals 5. For those of you who just went, wait, what was she talking about? The point is we don't have to do it here. An int is shorthand for an integer. We will be using those. Those are just whole numbers, 1, 2, 3, 4, 5, those kinds of numbers you can count easily. And a lot of languages make you tell the language that's what you're using. Python doesn't. So all we have to do is just basically put in a word and say it equals something, and we've got a variable. And in this case, the variable happens to be a poser scene. That's what this is. In fact, what we should be able to do is we're going to print. So print is just a shorthand, not a shorthand, is again a built-in part of Python, and it's just going to give us output that we can see here. It's going to open a little window. And this is not super interesting, and it's telling me it's of type scene. So type, if you're not sure what your variable is, this is a way you can figure out if it is the thing you think it is. So in this case, it is a scene. So we're going to get rid of that line. Okay, so we've actually done two things here. We've created a variable, but we've also called a function. We've called this function called scene. And we're going to do that again in a minute, or not the same function, but because we want to choose a figure. And we're simply going to start out, we're not going to make it super fancy yet, where it goes through or can choose one of these, all of these figures, bunches of these figures. For now, we're just going to go with whatever's selected at the moment. So, for instance, because I've done it like 5 times now, I think, but just because that's the area, this piece on the stole is what we're going to focus on, we're going to start with the stola selected. But again, we want a variable because that figure may change. So we're going to make a variable called figure, and we're going to set it equal to scene dot current figure. Now, this again is part of this built-in poser, and these are just easy, these are pretty easy to remember once you've done a little of it, but how I know this is if I go to our help menu and I bring up this PoserPython manual, I may not like it, but if I search for current figure, you will see, oh, there it is. This is the definition. It returns a figure. This is the stuff that is in, and delete current figure. This is probably the index for the built-in manual that comes for Poser in Python. I've looked these up before. These are ones I've used frequently, and you may see me from time to time if I'm not sure if I'm remembering the name of the function I'm calling correctly. Go look it up, but that's a lot. Like, that's 90% of what's in this PoserPython manual is just names of functions that you can call once you've imported Poser. Alright, so we've got another variable, and it is calling another function. This is a function on scene. Now, I will say we could have, if we wanted to, done these two things in one line. I could have said figure equals poser dot scene. I cannot type. I have to type this correctly. Dot current figure. And in fact, let's do this. Let's say figure 2 equals that. And what we're going to do now is we're going to say print figure and print, oh, you know what, we're going to do this slightly differently. So we're going to say figure is, and then we're not going to print, we're going to print figure 2 is, and then we're going to say figure 2. You may have noticed in there, and this is again one of the reasons I like this program, this does a lot of auto-completion for me as well as these pretty colors. It knows, it says, hey, you've typed this in before, it might be what you mean. We're also going to talk about here real quick on this print statement, the stuff in quotation marks will be printed as is, so figure is, figure 2 is, and then this comma and putting the word figure after it tells it to print that thing. So let's see what we get, and we may get something kind of strange only because I didn't pull up the name of the figure, and you'll see what I mean in a minute. That's what I expect to happen. Okay. Figure object at, and that's because of how the computer's keeping track. This isn't the name of the figure. If I say figure dot, oops, capitals, yep, keep hitting cap locks, name, if I call, there is a name function, and you will see this a lot. There's probably technically tons of these, but we can get names of figures and materials and actors and all kinds of things in Poser. So if we do it this way, and we run this script again, we're going to get something a lot more readable. We're going to get figure is dk stola v4, and figure 2 is also dk stola v4, because they're both doing the same thing. They're just doing them in different ways. So why not just write it all in one line like this? Well, here's the reason. We want to think about our ultimate goal, which is ultimately we don't want to just choose one item. In the long term, we're going to want our script to be able to choose multiple items. And so if we're declaring it this way, it makes it a little harder. It's not impossible. There's still ways we could do that, but we don't need to figure out the scene every single time. If we're running this, you know, how many figures do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we've got 11 figures in this scene currently. We don't need to tell it every single time, get the scene again. That scene is going to stay the same, but the figure is going to change. So this gives us a little more flexibility. This would work. But the bigger your scripts get, the better I think it is to break things out like this. So, all right, we are going to get rid of these. Actually, I'm going to say one more. Well, there's other ways you'll see print statements. I'm not going to worry about that now. One of the things you got to realize is there's not always a right way to write code. Sometimes there is, but there's often different ways. I find that more readable. Other people will write their code in different ways. Alright, so we've chosen a figure, we've opened a scene. So at this point, we've got two variables, scene and figure, and we've created those variables by calling some of Poser's built-in functions from the Poser library. So we're going to leave it here for the moment. If you do know a lot about coding, that may have been somewhat boring, although if you're not familiar with Python, it's really important to know that it's that simple to declare a variable, and you don't really want to worry about setting a type for your variable. That's just going to cause clutter, and Python doesn't expect you to do that. So that's all for now, and next time we're actually going to start building our own function because we want to find the materials on that figure. Well, I take it back. We're going to use a built-in function first, but we will build our own function as well. All right, so I will see you next time.